Morgan. We are the team, the FarmMB team, and today we are going to present how the different communication technologies works. So next, please.
Okay, one of the first technologies that we are going to talk about is the serial communication. And the serial communication works with a process of sending data of a bit at a time. And it also works with a receptor and a transmitter over a communication channel. This is a contrast to parallel communication, where several bits are sent as a whole on a link with several parallel channels. Next. The connections for the serial communication, this is the first one, when the model works as a transmitter. The configuration in this model will work as a transmitter for the model to know the output AB will be working as an output of data, and it will be connecting the 5B port to the pins RE and DE. With the Arduino, we'll be sending the data with the data input pin, and the model will be transmitting the data for the pins AB. Next. In the model working as a receptor, when we connect the pins RE and DE, the model will be working as a receptor, and the data will be received in the present pins, the receiver output, connecting the RO model to the RX to our Arduino that will be reading the data received. Next. And in the code, the simple communication here is unidirectional. As we said before, it works with a receptor and a transmitter. In Arduino, the Arduino through a potentiometer will be moving to a servo motor that will be connected to the Arduino only by two cables, like output A and B. And it will be connecting the Arduinos. There will be two Arduinos. This is the code for the first one. Um, And as we can see, it is a simple serial communication in the transmitter. Next. In the transmitter, the Arduino potentiometer is going to read, scale, and send serially. In the receiver, we will be receiving the data and moving the servo motor. And this is the code from the transmitter Arduino. Next.
The Bluetooth modules can transmit and receive data wireless by using two devices. This module can receive and transmit the data with the help of the host controller interface. Next, all the data entered in the module pass through the RX pin, then they are transmitted by Bluetooth to the connected device. The data that is received comes from the DX pin. Next. In the next code, the Android app was designed to send serial data to the Bluetooth mode. When a button is pressed on the app, the Bluetooth mode receives the data and sends it to the Arduino through the DX pin of the Bluetooth mode. Next.
So the next model that we are going to use is the GSM model, that is Global System for Mobile Communication. This is a digital mobile network that is widely used by mobile phone users. And okay, GSM use a variation of time division multiple access, that is TDMA, and we have three different digital modules that are TDMA, GSM, and CDMA. Next, please. So here we have the different connections or ports of the SIM 900 model parts. There are the voltage regulator, the EFI connector, power LED, power key. The important thing here to connect to the Arduino is the serial port and the software serial. There is the ports that we are going to connect to the Arduino, and then we have the SIM card holder. That is when the SIM card is going to stay, and the battery holder, that is the same. The battery is going to give power to the SIM 900. Next, please. So to connect to the Arduino, we need to connect the V7, that is the TX, and the 8, that is the RX pin, on shield to digital pin 7, and number 8 on Arduino. Um, as well, we using the software serial to tag to the shield, that is the SIM 900. That is the SIM 900. Mm, Then we need to power the shield using external power, that is the battery, that is a 5 voltage battery, or with the 5 volts adapter. Next, please. Okay, to the connection to the commands with the commands on the Arduino, we begin by including software serial library into the program. That is the first line. Then we need to create a constructor of software serial with the name myserial. And out here we are going to write the digital pin numbers as parameters, and then we need to connect the different RX and the TX of the Arduino. So the first task that we need to do is to set um, the baud rate of GSM and the with the serial monitor. That are the two next lines in the code. Okay, and the baud we should be set at the same baud rate, and we use the 9600 bit second here. So next, please. Okay, the program seeks user input by serial monitor on Arduino. So if the input is an a yes, we are going to send a message, and if it's a error, we are going to receive a message. We need to write two different models or functions that are the send message and the receive message. On the send message, the function that we create in the Arduino is going to send the message, and to send the message, we should set our GCM mode to text mode first. Then to the receive message is a function to receive a message, a SMS message, and we need to add the number in both of the cases to use these two functions. Next, please.
The next model is the TCP/IP model that allows an Ethernet connection. This will allow our Arduino to connect to a local network or to the internet. This model is based on the Ethernet controller ENC28J60, and it has a microcontroller that follows the IEEE 802.3 specifications. And it also has direct memory access, or DMA, hardware for IP checksums, and package filter. The connection to the Arduino is the following. The VCC pin from the module is connected to the 3.3 volts pin in the Arduino. The ground is connected to the ground in both parts. The SCK is connected to the 13th pin in the Arduino. The MISO is connected to the 12th pin in the Arduino. The MOSI is connected to the 11th pin in the Arduino, and the CS is connected whenever you want but you need to specify it in the code. For the connection with the Arduino, we need the following things in the code. First, you need to import the library, the EtherCard library. Then, in the two following lines of code, you will define the MAC address and the IP address. And finally, in the byte Ethernet, you will define the quantity or the size of the buffer to 700 octets. Then in the byte setup, you can initiate the module with the ether.begin command. And in that command, you need to specify the buffer, the MAC, and finally the port where the CS pin is connected to in the Arduino.